Okay, this is part 2 of our deriving terms for a given electron configuration series of videos. So in this video we're going to discuss the third case of electron configurations where we have two electrons in the same subshell, also known as equivalent electrons. So in this case we have electrons that have the same value of N and L, and we need to consider the Pauli exclusion principle in this case. So it gets a little bit more involved than our previous examples, but it's not too bad. So the example that we're going to work with is the NP2 configuration. So we're going to look at two electrons that are distributed in 2 of 6 spin orbitals. Okay, so remember our spin orbitals reference both a spatial and spin component. Okay, so even though there are only 3 p orbitals, each orbital can have electrons in a spin up or spin down configuration. So when we consider the spin component, we get a total of 6 possible spin orbitals that our electrons can occupy. Now, as we start getting into some of these more complicated situations or situations where we have multiple spin orbitals that our electrons can occupy, it's nice to have a shortcut to figure out how many total microstates you can possibly have for a given electron configuration. Okay, so rather than having to sit there and try to devise by hand all of the possible combinations of how your electrons can go into those 6 spin orbitals, we can do this nifty calculation here where we just take into account the number of spin orbitals, which is given by G, and our number of electrons, which is our N. So if we plug those values in for our current example, so remember we have 6 spin orbitals that our 2 electrons can go into, so we have 6 factorial over our number of electrons, which is 2 in this case, and then we have our spin orbitals minus our number of electrons going in here. When you do that calculation, you should end up with a total of 15 microstates that are possible for putting those 2 p electrons into those 6 possible spin orbitals. Okay, so like I said, it's kind of nice to have that little shortcut to determining the number of microstates for our electrons for a given situation. But here are the possible 15 microstates that you would end up with if you were to put these 2 electrons into your 3 p orbitals. Again, we have options for spin up and spin down. Okay, so that's where our 6 spin orbitals come from. All right, so these are all the 15 possible options. You can pause and take a look at them and verify for yourself that every possible combination of spin up, spin down, and paired or unpaired are represented there. But those are all of our options. Okay, so as we try to determine the different terms that are represented by these different microstates, we're going to take a stepwise approach to putting all of these different microstates, assigning them to different terms. All right, so our first step in this process will be to determine the maximum M sub L possible. Okay, so it's nice to have this little chart here so we can kind of visually pick out the situations that we want. So we're looking for a maximum M sub L. So if we look down our row here, we see that we get a maximum M sub L right here of 2. Okay, so maximum M sub L possible is going to be 2, and that is our situation right here. All right, so we see that maximum M sub L value arises when we have our 2 electrons located in that m sub l equals +1 orbital. All right, so now our next step, once we've identified our maximum m sub l possible, is to determine the maximum m sub s possible for that configuration. So max m sub s possible for our max m sub l. Okay, so in that case, our maximum m sub s possible we see by looking at our arrangements of the electrons for this situation is going to be 0. Okay, because we've got those paired electrons. Now, yes, it's possible to get a larger value of m sub s, right, with some of these other arrangements that we have here. We get m sub s values that are larger than 0, but remember we're looking for the maximum m sub s possible for the maximum m sub l that we've determined up here. Okay, so that's leading us to this situation. Our max m sub s there is 0. All right, so now we take this information and use it to help us to determine what our big L, our total angular momentum, and our big S, our total spin angular momentum values can be. All right, so here our possible values of L, based on that maximum m sub L value equal to 2, means that L can be 2 here. Okay, so if we have an L of 2, that means that we get maximum, or possible m sub L values of -2, -1, 0, +1, and +2. Okay, so what we're doing here, again, is using that maximum m sub L value to essentially tell us what our maximum possible value of L can be. Okay, so if we have an m sub L of 2, we know that our maximum L value can be 2. All right, so if our maximum L value is 2, we know that we have additional options for possible m sub L values of -2, -1, 0, +1, and +2, right? So remember, m sub L ranges from -L to +L. Okay, so we'll do the same thing with our m sub s. So we know we have a maximum m sub s of 0, so that tells us that our maximum s that we can have in this situation is 0. Okay, with an s of 0, we know that our possible m sub s options can only be 0, right? So we just have that one possible value there. Okay, so now we are going to take our combination of L and S. Okay, so we've identified our big L and our big S for this particular set of microstates. Okay, so we're going to assign a term symbol based on that combination of L and S, and that turns out to be a singlet D term symbol. So we get, remember, the D comes from our L equals 2, so 2 corresponds to a D designation, and then our multiplicity up here in the corner, that comes from our 2s plus 1. Remember, 2s plus 1 here is going to equal, not 0, it's going to equal 1. So we get our singlet designation. Okay, so we get our singlet D term symbol for these cases. Now we can assign this term symbol to all of the possible combinations of m sub L and m sub s that we have for those given values of L and S. Okay, so we've already said that we get possible m sub L values of -2, -1, 0, +1, and +2. So we get 5 options for m sub L that fall within that L equals 2 quantum number, and then we get the one value of m sub s that falls under that s equals 0 quantum number. Okay, so we get a total then of 5 microstates that are going to fall under our singlet D term symbol designation. Okay, so let's just knock those out. So that's obviously our 2, 0 option. So we're just going to find all of the options that correspond to our different combos of m sub L and m sub S. Okay, just to clear out our microstates a little bit. So we've got a 2, 0. We should have a 1, 0. So we can get rid of that. We should have a 0, 0. We should have a minus 1, 0. We should have a minus 2, 0. And so we'll scratch those ones off. So there's 5 microstates that we've been able to check off under our singlet D term symbol. Now you might have noticed that there are some other options that we could have chosen for the minus 1, 0. So there's another one here. So yes, there are duplicates, right, for those m sub L and m sub S's. At this point, it's just kind of arbitrary which one you're choosing. Okay, we're just essentially doing an accounting of all of our microstates. Okay, so when all is said and done, we should end up with term symbols that account for all 15 of these microstates. The specific placement of those microstates within the terms sometimes is unfortunately a little bit arbitrary, and I know that's a little bit unsatisfying, but we just have to come to terms with that and move on. Okay, so next step in our approach here for assigning our term symbols is going to be to just simply select the next largest m sub L value. So we've already crossed out our m sub L, max m sub L of 2 in our first step. Okay, so now we're just looking for our next largest value of m sub L that we have left. So looking at our possible values over here, we see that our next largest m sub L value is going to be m sub L equals 1. Okay, so if we have a maximum m sub L value of 1 now, that is going to lead us to the conclusion that our value of L must be 1. So possible m sub L values for L equals 1 will range from minus 1, 0 to plus 1. Okay, so I'll just note this one as max m sub L, or new max m sub L. Okay, so once again, just finding your new maximum m sub L value, that leads to your possible maximum value of L, and then from that value of L, we know we have these possible values of m sub L ranging from minus L to plus L. All right, and then we do the same thing for our m sub S. So our new maximum m sub S for our maximum m sub L here is 1. Okay, so we have corresponding largest value of m sub S equals 1. Okay, so same association there. So m sub S equals 1 leads us to a possible maximum S value of 1, which gives us possible m sub S options of minus 1, 0, and plus 1 this time. So again, new max m sub S for that. Okay, so now we again go down the line looking at the different combos of m sub L and m sub S. Okay, that will tell us the microstates that will be covered by this particular combo of L and S. All right, so in this case, again, we want to focus on these values to come up with our term symbol. Okay, so L equals 1 gives us a P designation, and S equals 1 should give us the triplet. So if we do 2S plus 1, we get a triplet P. Okay, so now we can cross off all of the microstates that correspond to our triplet P term symbol. Okay, so that's going to be all these different combos of M sub L and M sub S. So we'll have -1, -1, -1, 0, -1, +1, and so forth. So we're going to get a total of 9 microstates that are going to fit under this triplet P term symbol. So we can just knock them off. Okay, I'll do another color. I'll do these ones in green. All right, so we've got 1, 1 gets taken care of, 0, 1, -1, 1, -1, try to keep these straight, 0, -1, -1, -1, we get a 1, 0, a 0, 0, and a -1, 0. Okay, so there's 9 of our microstates that are accounted for with these different combos of M sub L and M sub S, okay, that fall under our triplet P term symbol. Again, feel free to pause and take a minute to satisfy yourself that all of those states that I just crossed off are combos of these M sub L and M sub S values. Okay, so now we are left with 1 microstate. All right, so we have M sub L and M sub S equals 0 for this one that's left over. Okay, so here we know that M sub L, our next maximum M sub L, if you will, is M sub L equals 0. That leads us to L equals 0. Okay, only possible values of M sub L in that case would be M sub L equals 0. So new max M sub L of 0. And then again with our M sub S, new max M sub S, also 0, leads us to a big S of 0. Only options for M sub S in that case also going to be 0. Okay, so we see that we only get one possible combination of M sub L and M sub S, which means that's 1 microstate. And if we determine the term symbol that corresponds to those values of L and S, okay, remember it's the L and the S that you want to put your term symbol together. All right, so here an L equals 0 gives us an S designation, and an S of 0 will give us a singlet. Okay, so our 2S plus 1 equals 1 in this case, so we get our singlet S term symbol. All right, so then that takes care of our last microstate. Okay, so now hopefully you can see that all of those 15 microstates for our P2 electron configuration are now accounted for with these 3 term symbols, our singlet D, triplet P, and our singlet S. Okay, so we get 5 microstates from the singlet D. We got a total of 9 microstates from our triplet P, and we get 1 microstate from our singlet S. So we do get our total of 15 total microstates. All right, and the last thing I'm going to mention on this is again, another little shortcut for determining your number of microstates. Just put that up here, of microstates within a given term symbol is given by 2s plus 1 times 2l plus 1. So we've seen that that form show up when we talk about degeneracy of our rigid rotor. Okay, so same kind of idea there. So here we have, if we take our second section as an example, so 2s plus 1 would give us 3 times 2l plus 1, so that would give us another 3. So 3 times 3 equals our 9 microstates. Okay, so again, this is just kind of a shortcut for figuring out how many microstates are going to fall within each given term symbol. So if you do that 2s plus 1 times 2l plus 1 for each one of these, you should get 5 for the singlet D, 9 for the triplet P, and 1 for the singlet S.